This video is an introduction to vectors. Now, a vector is a quantity that has both a magnitude, that is size, and direction. So let us draw a vector. So here we go. Here is a vector represented by an arrow. Now, to give it an idea of size, well, let's say that is maybe 10 centimeters long. Okay, and well, what is the direction? So we'll create a reference for it. We'll assume, as often is the case, that north is towards the top of the board, and then we have, of course, north, east, south, and west. So we can define that vector as having a size of 10 centimeters in the direction somewhere between north and east. Okay, and in fact what we could say is, okay, let's call that angle there, say 15 degrees. So that vector is 10 centimeters at 15 degrees to the east, or 15 degrees to the horizontal, however we define it. So that would be a vector, and that would be known as displacement. Whereas if it was just the magnitude, it would be the distance would be equal to 10 centimeters, but the displacement would be equal to, so displacement would be 10 centimeters in the direction 15 degrees to, if you like, towards north of the east, or 15 degrees to the horizontal. That is assuming that the east is the horizontal. So that gives you the idea of vectors. Now, what we'll do is we'll show you another vector. So that is displacement and distance. And I'll come back to the difference between displacement and distance in a moment. And let's have a look at a more common variety of vector, which is velocity. Now, velocity is a vector, and whereby speed is not a vector, and that's known as a scalar. Now, a velocity, so you could say the velocity is something often is 5 meters per second, and also maybe the same object, or at a different time, has got a speed of 5 meters per second. So what is the difference? Well, we haven't finished defining the velocity. So for the velocity, we'd have to say, and often physicists, physics teachers don't do this. So velocity, 5 meters per second due north, in the north direction. Okay, and speed doesn't make any difference at all. You do not define the direction. So whereas speed is to velocity, we have displacement is to distance. Okay, and these are the two that we should really work with most, but often we call them speed and distance. It doesn't always make a difference. Okay, so now I'll give you a quick physical examples of these. So an obvious example for velocity and speed is, for instance, okay, so let's say a car. I'm going to draw a terrible car, I always do. Okay, a car, right, a car driving along at 15 meters per second, and we'll say that is due east. That is the velocity. So that's the velocity. Now, that is a velocity. However, if the car was going round, came to a roundabout, so here's the car coming along, and it turns direction like that, okay, the velocity would change, because here it's 15 meters per second due east, but it's changing, and then in fact, it's here, it's going 15 meters per second due west. So there's a change in velocity. In fact, it's accelerating as it's going around the corner there. Now, if it was speed, the speed would be 15 meters per second at every point on Earth. Because you're not defining speed with direction, the speed doesn't change, but the velocity changes and it accelerates because velocity is rate of change of displacement or distance, sometimes called, or distance with respect to time. Okay, now let's have a look at the idea of displacement and distance. So let's take 2 points here, or 2 places. Let's say Norwich, and let's take a town, let's say Horsted. Horsted, I believe it's pronounced. You can go from, there you go. Say you go from Norwich to Horsted, you go in a wiggly line or a straight line. Now in this case here, if you went the shortest possible route, the displacement and the distance would be the same. Let's call that 10 miles. However, in this case here, the distance here might be 15 miles, so the distance here travelled is 15 miles, but the displacement would still be just 10 miles. Displacement being the if you like, distance in a straight line, displacement per place. Okay, now we have another idea about it. So let's say we have, here we are, Norwich and Horsted again. You could go sort of straight as the crow flies to Horsted and back again. In that case here, the total displacement would be equal to 0 because you come back where you started again. So displacement is 0, but the distance travelled would be, so 10 there, 10 back, would be 20 miles.